I have started growing American giant sunflowers, which can grow up to 14 feet tall. I want to start breeding them to make them taller so that all my neighbors can see them over the top of my very tall fence. The mean height of my starting population of sunflowers is 9 feet or 108 inches, and the standard deviation is 7 inches. To perform my selective breeding experiment to try to grow taller sunflowers, I first began by selecting the tallest 10% of my original population. My broad sense heritability was 0.85, and my realized heritability was 0.67. I first had to calculate my truncation point to find the top 10% of my population so that I could breed them together. I used the formula for truncation point to determine that for my original population, the top 10% were beyond the value 116.974. I used my realized heritability to calculate some predictions about my offspring generation. The values for Z, or standardized selection point, and I, or selection intensity, were found based on the chart used in class. Z is equal to 1.282 and I is equal to 1.755. Using my realized heritability, which is equal to a response to selection divided by selection differential, I was able to calculate that the response to selection of my offspring generation should be 8.231. I used the same formula for realized heritability and solved for S to find that my selection differential was 12.285. Using this information, I found the mean of my selected parents' heights using the formula S equals the mean of the selected parents minus the mean of the original population, which came out to 120.285 inches. I then breeded, germinated, and planted my F1 generation of sunflower plants to see if my experiment worked. I expected the offspring population to have a mean height of 116.231 inches, which I calculated by adding the mean of the original population plus the response to selection. The resulting curve plotted on top of the original curve looks like this. I have also labeled R and S on the graph to demonstrate them visually, as well as shaded in the top 10%. If I were to perform the selective breeding experiment indefinitely, in later rounds of selection the response to selection would decrease because the sunflowers would begin reaching their maximum potential for height, which is around 14 feet. Although some of the growth of my sunflowers is determined by their environment, I have minimized that by growing them in almost the same conditions. The rest of the variation in the heights of my sunflower plants is caused by genetic effects. As I repeatedly select for taller and taller plants, the variation within these generations becomes smaller because there is a maximum height that a specific breed of sunflowers can grow, and each subsequent generation is closer and closer to that threshold. There is less of a chance that a significant change in height will occur when the variation in my population is smaller, which is why R will get smaller over time.